let's do IXL 7th grade AA.13. Go to Learning. Go to 7th grade. Go to AA.13, surface area of cylinders. What is the surface area of this cylinder? Use pi equals, or pi is approximately equal to 3.14, and round your answer to the nearest hundredth. Okay, so to find the area of to find the surface area of a cylinder, we need to find the area of the two bases, both of which are circles. So the area of the top base, which is a circle, and the area of the bottom base, which is a circle, and then add the area of this lateral surface, which is actually, if you stretch it out, it's a rectangle. So the area let's remind ourselves how to find the area of a circle. You go over here to Friedman Math, and then find circles over here. It's on page 13. So let's scroll down to page 13, and so here the area of a circle, A stands for area, is just pi r squared. So we're going to go back to IXL now. And, maybe it would be a good idea if, actually, before we did that, let's just break this up. So basically, this top here, we have a circle with a radius of 6 centimeters. So let's draw that out here. We have a circle with a radius of 6 centimeters. I didn't do a very good job there. That should be starting from the middle. So the radius is 6 centimeters. And we have another circle on the bottom, also with a radius of 6 centimeters. Then, if we were to unravel this, we would get a rectangle. Where the height is 3 centimeters. And the length would actually be the same as the circumference of the circle. So I'll come back to that in a minute. Right now, let's use our pi r squared formula to find the area of each of these circles, which are the same. So we have pi times 6 squared, because 6 is the radius. So 6 squared means 6 times 6. It doesn't mean 6 times 2. It means 6 times 6, which is 36. And then we're going to do pi times 36, but IXL told us to approximate pi with 3.14. So let's do that. So we're going to do 3.14 times 36 equals 113.04. So what does that mean? That means the area of each of these circles is 113.04 square centimeters. So this one is 113.04 square centimeters, and this one is also, because they're the same. And now let's figure out the area of this part of it. And again, if we unravel this, we just get a rectangle, and the height would be 3 centimeters, but the length would be the same as the circumference of the circle. So let's remind ourselves how to find the circumference of a circle, that would be, the circumference is equal to 2 pi r. So the length here would be equal to 2 pi r, which is 2 times pi times 6, because the radius is 6. And then 2 times 6 is 12. We can multiply those first, so we have 12 pi. And now again, we'll just go ahead and use the calculator to do 12 times pi. We're going to use 3.14 for pi. So 12 times 3.14 is 37.68. That would be centimeters. So now to find the area of this rectangle here, we would have to do 37.68 centimeters times 3 centimeters. All right, and I'm going to use the calculator for that also, rather than doing it by hand. So, okay, so it's also 113.04, just like the circles. That is not always going to happen. Yeah, so it happened this time. So this is 113.04 square centimeters. So now we're just going to have to add all of these up. This plus this plus this. So, well, actually, that wouldn't be too hard. What would that be? That would be 339.12. If we do this plus this plus this, we would get 339.12 square centimeters. Okay? Okay, what is the surface area of this cylinder? So again, we have 2 circles. 1, 2. Each circle this time has a diameter of 16 centimeters. Now, if the diameter, you can see this dotted line is going from here all the way over to here. So that is the diameter. That is not the radius. We want the radius in order to use the area formula. We want r, we don't want d, which is the diameter. But it's very easy to get the radius from the diameter. We just take that diameter and we divide it by 2 to get the radius. So instead of writing 16 centimeters for the diameter here, I am going to erase that and just say that the radius would be 8 centimeters. Why? Because 16 divided by 2 is equal to 8, so I just put that over there. Okay? And this one would also be 8 centimeters, because they're the same. The top and the bottom of this cylinder are the same. And now we just use area equals pi r squared to get the area of those bases. So that would be pi times 8 squared. 8 squared is 64, because 8 times 8 is 64. And now we'll go over to the calculator and do 3.14, which is what we're using for pi, times 64 is 200.96. So each of these would be 200.96 square centimeters. Now, when we unravel this, I hope you watched the video on finding the surface area of a cylinder, which I put on Friedman Math. It was It's only a few minutes long, and it does a good job of showing you why the length of the rectangle that you get is equal to the circumference of the circle. Because if we imagine unraveling this cylinder to get the net for the cylinder, like in the other IXL exercise for this week, you could just see that when you unravel it and you get the net, this part over here is equal to the circumference of the base of the cylinder. And I'm not doing a very good job of showing that they're the same length, but this and this should be the same length when you unravel the cylinder. So anyway, we need to find the circumference of the circle with the radius of being 8 centimeters. So to find the circumference, we're going to do C equals 2 pi r, but our r is 8, so we have 2 times pi times 8, which is equal to 16 pi, which is equal to, it's going to be about 50. So 16 times 3.14, so 50.24. That would be the length of this rectangle. And the height over here is equal to 4 centimeters. That's just coming from right over here. So if I want to find the area of this rectangle, I would have to do 50.24 times 4. It's going to give me, what, 200.96? Yeah, 200.96 centimeters. That would be, sorry, that would be square centimeters, because this is centimeters, this is centimeters. So centimeters times centimeters is centimeters squared. So I'm getting the same result that I got over here. That is not always going to happen. So that was just a coincidence, right? It happened to work with the value of 4 being the height of this rectangle, but if we just changed the height of the rectangle to something else, 5, 6, 7, or literally anything else, then obviously we would have gotten something different. So this and this are not always going to be the same. But remember, this was for the area of both of these circles. So we have 200.96 in both of these. So we have to add up 3 200.96s. Now I could just multiply by 3 here, obviously, but I want you to get in the habit of adding them, because again, it was just a coincidence that all 3 of these turned out to be the same. In general, 2 of them will be the same, because the base and the 2 bases of the cylinder would be the same, but the area would in general not be the same as the area of the bases. So we're going to get 602.88 square centimeters. Okay, so we have another one, which is the same. Again, I'm just going to do real quick here. We have pi times r squared, but the radius is going to be half of this. You see this dotted line is going all the way across, so that means that's the diameter. The radius should only be half. So if all the way across is 10, then half would be 5. And whoops, I just erased my pi r squared. So our pi r squared is going to be pi times 5 squared. But 5 squared, meaning 5 times 5 is 25. So we get pi times 25, which is approximately 75, because pi is about 3. But it's going to be a little bit more than 75. So 3.14 times 25, we get 78.5. That would be square centimeters. And remember, we have 2 of these, right? One for the top, and then one for the bottom. So this would be 78.5 square centimeters. The bottom would also be 78.5 square centimeters. Okay, so we should do here, to get both of them together, 78.5 times 2, which is what, 157. 157 square centimeters. This is square centimeters, this is dimensionless, so we get square centimeters as our answer. But then we also have to do this part of the cylinder, which is a rectangle. So we would have to do 2 pi r, which is equal to 2 pi r now. Remember, it's the circumference. We want the circumference of the circle, not the area. So I'm using 2 pi r, again, because the length of this rectangle is equal to the circumference of the circle. If you were to unravel this, then the length of this rectangle is coming from the length all around the circle, which is to say the circumference of the circle. So we have 2 pi r. Our radius is 5, because the diameter was 10. The radius is half of 10, which is 5. So we have 2 times pi times 5. 5 times 2 is 10. So we have 10 times pi, which is going to give us 31.4. I don't need a calculator for that, because when we're multiplying by 10, we just move the decimal point one space to the right. So we have 31.4 centimeters for the length of that rectangle. The height of the rectangle is 3 centimeters. And then we do 31.4 centimeters times 3 centimeters is equal to 94.2 square centimeters. Okay, so what do we have here? We have 94.2 square centimeters plus 78.5 square centimeters plus another 78.5 square centimeters. But we already multiplied this by 2, and we said that this was 157 square centimeters. So now we just have to add these two together. So I'll just add them up with the calculator. 157. No, it was point nothing. So plus 94.2. We get 251.2 square centimeters. All right. What is the surface area of this cylinder? Looks like this is the same as the last one. So I'm going to jump ahead to the next level here. What's the surface area here? Again, this looks exactly the same, except there are decimals here. So you just want to make sure that you are rounding your answer to the nearest hundredth, because that might matter for some of these. So let's just quickly talk about rounding. Go to the reference pages here. Where's rounding? I have it here. Here it is. On page 1, rounding. It's taking an ironically long time to get to page 1. Okay. Alright, so just remember, if we are rounding... Oh, perfect. I have an example of rounding to the nearest hundredth. So if we are rounding, step 1, we're going to locate the digit we're rounding to. In our case, the digit that we are rounding to is the digit that's in the hundredths place. Let's remind ourselves where the hundredths place is. That might be hard to see, but here's the hundredths place right over here. That is 2 decimal places after the decimal point. So that's the hundredths place. So step 1 is to locate the digit that we're rounding to. So in this example here, if we're rounding 7.92841 to the nearest hundredth, then here is the hundredths place right over here. So that would be what I call the rounding digit. So that's why I put an R right over here. Step 2 is to locate the digit 1 space to the right of the rounding digit, and that's what I call the decision digit, because that's the digit that we're going to look at to make our decision. The decision being whether we should bump this up 1 or keep it the same. So I put a D here because that's our decision digit. And then step 3, if the decision digit is 0, 1, 2, 3, or 4, then we should keep the rounding digit the same. But if the decision digit is 5, 6, 7, 8, or 9, like it is here, it's an 8, we will bump the rounding digit up by 1. So we will, in this case, since this is an 8, we're going to bump the rounding digit up by 1. So 2 plus 1 is 3. And then and that's why you see a 3 over here. Now, why is there nothing after this? Because step 4 is eliminate everything after the rounding digit. Okay, so we eliminate everything after the rounding digit, so now all of this is gone, and we just get 7.93. So this problem over here is just like the last problems, but maybe if you have to end up rounding to the nearest hundredth, now you know how to do that. So I'm going to, again, just jump ahead to the next level. The challenge zone. The surface area of this cylinder is 2,285.92 square feet. What is the height? Again, we're going to approximate pi as 3.14, because remember, pi is irrational. That means it goes on forever without repeating. The decimal expansion goes on forever without repeating. So this is just an approximation to pi. And we're going to round our answer to the nearest hundredth. So in this case, we have to find the height of the cylinder, not the surface area of the cylinder. So how are we going to do that? We're going to write an equation here. We're going to start off with pi r squared. What do I know about pi r squared? I know that pi r squared represents the area, or it's what we use to calculate the area of the base over here, but also the bottom part, also the bottom base, over here. So we actually have two bases which are both equal to pi r squared. So really, we should be multiplying this by 2, not because that's the formula for the area of a circle. Remember, the formula for the area of a circle, whoops, I'm on the wrong page now. Here we are. The formula for the area of a circle does not have a 2 in front of it. I'm only putting a 2 in front of this because I have two bases which are exactly the same, right? So in other words, I have this one, which is equal to pi r squared, but then I have another one over here, which is also equal to pi r squared. But rather than saying pi r squared plus pi r squared, I'm just going to write that a different way, and I'm going to say 2 pi r squared. Okay, but now I have to add the area of this part over here, which, remember, that was a rectangle, and the length of the rectangle was equal to the circumference of the circle, which is 2 pi r. So this 2 is here because the circumference formula actually does have a 2 in front of it. And now we're interested in the circumference. So we're going to put 2 pi r over there, and we're going to say that the height is h, right? So in order to find the area of this rectangle, we would have to do, and we've done this before, but we were using actual concrete numbers. Now we're just doing everything algebraically. The area of this rectangle would be 2 pi r times h, because we're multiplying the length by the height. Now we're going to take this and we're going to put it into our formula that we are creating for the total surface area of the cylinder. So we already have the two bases with the 2 pi r squared. Now we're going to add 2 pi r h, and this expression that we have now represents the full surface area of the cylinder. But we're told that the total surface area of the cylinder is 2,285.92 square feet. So we can just take this and set this all equal to 2,285.92 square feet. I'm just going to leave the units out of it for right now. And now, what's our next step here? Our next step is just to take what we know and plug it into our formula. So we know that from here to here, so now the dotted line is only going halfway. That means that this is the radius. Let me just give you a brief reminder. Remember, this is the radius of a circle is halfway. The diameter is the full way. The circumference is all the way around, and the area is the space that's inside. So we have the radius of the circle is 13 feet. So let's just plug that in everywhere that we see an R. So that would be over here, and that would also be over here. And now let's just write the rest of the equation exactly the same as it was. So we have 2 times pi times 13 squared, don't forget that exponent is there, plus 2 times pi times 13 times h equals 2,285.92. All right, so now we have 13 squared, which is 169. 13 times 13 is 169. Times 2 times pi. Right? So you know what? I'm just going to put all that. Let's work that out. So you can do that. We'll do it step by step. So we have 13, but then this exponent is telling us to multiply the 13 with itself. So we'll do times another 13 times 2 times pi here is 3.14. So we get 1061.32. Plus, now we have to do, now you're saying to me, Mr. Friedman, isn't this exactly the same as this? Can't we just put this number over here also? No, because here there is no exponent. Here there was an exponent of 2, so we had these two 13s over here. So I could just take this and divide by 13, but I'll just do the whole thing again, just to show you. Oh no! Whew! Okay, I got it back. That's not what I wanted to erase. This is what I wanted to erase. Again, I'm doing it the long way. I could have just taken that answer and divided it by 13, but I'll just do it the long way again. So 2 times pi times 13. It really doesn't matter what order we multiply in. So there's my pi, 3.14, times 13 equals 81.64. What did I forget? H. Well, I can't put H into the calculator, right? So we're just going to leave the H right over here. And then equals 2,285.92. Now we're going to subtract 1,061.32 from both sides. Now you can go ahead and use a calculator for this. I'm just going to do this all in my head. Let me see. Okay, done. I did it in my head. Now I'm just going to put it on the calculator just to show you how to do it, because I already figured it out in my mind. See, that was for you. I didn't have to do that. So this over here is 1,224.6, and that is equal to 81.64 H. And now our last step is we're going to divide both sides by 81.64. So we would get H is equal to whatever this turns out to be. So now we're just going to, I already have this in the calculator, so I'm going to do, I just want to make sure I put everything in correctly to begin with. Yeah, so now I'm going to divide by 81.64. That's going to give me 15. Well, so we don't even have to round to the nearest hundredth for this one. Okay, so that would be the height of this cylinder. Right. This question is the same as the other one. So, all right, I'll just do one more example here. We have our formula, which is 2 pi r squared plus 2 pi r h. We could actually factor out a 2 there. Whoa, what the heck am I doing? It's not an exponent. Equals, we could write this a different way. We could factor out a 2 and then put the rest of these in parentheses, but that's okay. I'll just leave it this way. Equals 116.494. So now we're going to plug in our radius, which is 3.5. So we have 2 times pi times 3.5 squared plus You know what, maybe this would be easier if I did factor out the 2 pi. Would that make things easier? Yeah, probably would. But I'll keep it this way. I already started writing. All right. Next step, I'm going to take this. I'm going to do it in my head, and then I'm just going to show you what to put in the calculator. So I already figured it out in my mind. But just to show you guys, we have 2 times pi is 3.14 times 3.5 times, so actually let me just pause here because this should be what I write over here. So just 2 times pi times 3.1 times 3.5. So I'm going to write that right over here. But then, since I have this exponent over here for this one, I should multiply this by 3.5 again. And that's going to give me this one. So that would be 76.93. Equals 116.494. We're going to subtract 76.93 from both sides. Okay. So I'll do 76.93. So actually, you know what? I'm just going to keep this in here, and I'm going to do this minus 116.494. Now you're going to say to me, wait a minute, Mr. Friedman, this should be 116 minus 76. You did 76 minus 116. Well, yeah, that's true, so I didn't technically put it incorrectly, but I know that this is just going to give me the same absolute value, it's just going to be negative. So when I hit equals here, it's going to give me a negative answer, but I can just ignore that, and I can put over here 39.564. Okay, and so that cancels. So we have 21.98H, and then our last step is to divide by 21.98 on both sides. Okay, so we get H equals, take this, and I still have the negative here, so when I divide this by 21.98, it's going to give me a negative again, because a negative divided by a positive is negative. But again, I'm just going to ignore that, and I'm going to say 1.8 is the answer. Okay, so 1.8 is the height of that cylinder. And it told us to round to the nearest hundredth, but we don't have to round to the nearest hundredth because our answer did not even go up to the hundredths place. So we'll just put that in there. And hit submit. And okay, so it looks like I'm getting another problem exactly like the last ones. So I'm going to end it there. Hope that was helpful. If you have any questions, please reach out to me, and have a great day.